Welcome to my talk Kubernetes Security a Developer's Nightmare. My name is Andreas Falk. I'm working for a company called Novatec Consulting located at Stuttgart, Germany. I'm mainly working as a consultant developing custom software applications for big enterprise companies like in the insurance branch or in the automotive branch. I'm also a member of the OWASP community and the OpenID Foundation. So I'm always very keen on application security topics as well, like authentication with OAuth and OpenID Connect, Kubernetes security, and security awareness in general. So the first question that always arises at my talks is what about the slides and where can I find the code? So the good thing here is that you can find all the stuff on my GitHub repository with corresponding practical demos, which unfortunately I cannot show live in my presentation today due to time restrictions. So let's start with the path for secure development on Kubernetes. So we will start at application security. The application security is the basics of all the things. So if you have an insecure application, then putting this application into Kubernetes cluster does not improve anything. So Kubernetes does not make you safer from authentication failures, authorization misses, or having SQL injections. So you have to make sure that your web application is developed in a secure way and is authenticated, authorized in a proper way, prevents SQL injections by using prepared statements, prevents cross-site scripting and cross-site request forgery attacks, and also protects your data by using good cryptographic algorithms. So the 101 on application security is use input validations for all types of inputs you are using and getting inside your system. Use output encoding to prevent all kinds of cross-site scripting. To avoid SQL injections, use your Hibernate framework, Spring Data that is using prepared statements out of the box to avoid that. Enforce authentication, authorization on all endpoints, for example, by using Spring Security that secures all that out of the box. Never implement your own cryptographic algorithm or your own session management. Use frameworks like again Spring Security. And also always check your third-party dependencies for vulnerabilities. So even if the bad code does not arise in your own code, it can be brought into your system by just adding some third-party dependency. Then automate all the things by using static and dynamic application security testing as part of your CI/CD pipeline. That's also really important. If your application is secured, then the next step would be to put that application inside your Docker container, which brings us to container security. Here I start just with the basics to make sure that everybody is on the same page. What is the difference between a virtual machine and between a container? So basically a virtual machine has some kind of hypervisor running on physical hardware if you have a type 1 virtual machine monitor. And on top of that hypervisor you have running your different guest operating systems, so you can run a Linux, a Windows system on that hypervisor, and above that guest operating system you can just install your guest applications. Almost the same is true for the type 2 virtual machine monitor, with the difference that here the virtual machine monitor is not running directly on physical hardware. But for both approaches, you have a complete isolation between your different guest operating systems controlled by that hypervisor or virtual machine monitor. So if we now look on containers, the big difference here is that containers really run on the same base Linux host, the same Linux kernel actually. So they share the base Linux kernel. They share the same Linux technology. They are just isolated via what is called Linux namespaces. So as you can see, Docker containers or RKT containers, so you can also use other vendors apart from Docker, are completely based on Linux technology. So that's why it's really crucial for you to also learn Linux basics to understand all the important mechanisms of containers. So as I have already mentioned, Linux kernel namespaces are used to separate the different containers running on the same Linux host. So you have separate process IDs for each container. You can have separate network stuff on running on your different containers. You have several mount points to file systems, separate user and group IDs. And you can also have control groups for each container. So what is a control group? So a control group basically puts resource limits on your container. So it's a bad thing to exhaust all the host resources by just running one container that consumes all the resources. That would make it impossible to run several containers on the same host system. So that's why you should use control groups to limit your CPU usage, your memory, using devices, processes, and network resources. If you're using Java to develop your application, then you should be aware that you should at least use OpenJDK 8 update 192. This is the first version that is really container aware. Older versions just ignore the resource limit set and will just use the complete CPUs, complete memory from your host system. They don't care about setting that resource limits. My recommendation here is also not using Java 8, but also going forward using Java 11. So Java 8 is already quite old, quite outdated. So go forward and just update your applications using Java 11. So then you're safe and you are container aware by default. Next mechanism on Linux, which is really important, are the Linux capabilities. So in ancient times, before having Linux capabilities available, you had basically two choices to set up users on your system. Either you have a user that has complete privileges as a sysadmin on the system, or you have the other user that just acts like a standard user without any privileges. But now using Linux capabilities, you can fine-tune all that things and just set the capability capnet admin to a user, for example. So only set the really required privileges for users and running the processes. With Docker, you can also drop all the unnecessary capabilities, like in an example command line on the bottom. Here see a usual use case you will need for running containers like Apache HTTP server or Nginx server, which typically requires to bind to port 80, which is not allowed for standard users to bind to. Only ports above 1024 are allowed usually. So if you want to bind to that port 80, then you need the capability NetBind service. So you drop all the capabilities not needed and just add NetBind service, that's all. So if you're building container images, usually you write what is called a Docker file. Here you include a base image that you want to use, like Alpine, for example. Then you put in your Docker file additional package installations that you need for your Docker image. And then you also include your application that should run as part of your container image. Then you build your container image, add it to a container registry, just upload it to Docker Hub, for example. And now if you issue the docker run command, then Docker just fetches the container image from the container registry and runs it on your Docker environment. And still remember, Docker containers just share the same Linux host in the same Linux kernel. So by default, if you just run a container out of the box with only standard Dockerfile statements, then it probably will run with a root user with a standard set of capabilities set to that user. But the easy thing to change that behavior is just to add a user to in your Docker file to your container, and then with the user directive, you point your Docker file that it should use that user instead of a root user. And also remember to restrict the capabilities of running that container image. So if you're writing a Docker file, then I already mentioned that usually you include a base image. There are lots of well-known base images available on Docker Hub, like Node.js, Postgres, Nginx. The bad news here is that all these base images have known vulnerabilities inside. It is a bit better if you use the reduced variants of such images, like for Node.js 10, the Slim variant, or even the Alpine variant, that have a drastically reduced amount of vulnerability. But always be aware that these images tend to have vulnerabilities inside. And also always check where you load your base images from. So always load it only from trusted registries, and also only use well-known images, not exotic ones where you don't know if they bring the keylogger and some backdoors by default. Because of that vulnerabilities inside container images, it's always a good idea to do image security scanning. The typical image security scanner scans for operating system vulnerabilities, both on base image level and also as part of the packages that you installed in your Docker file. And it also scans all the third-party dependencies on your application for vulnerabilities. And luckily there are free scanners available on the market, open source scanners like Trivy, like Anchor or Claire, can be just easily installed. So Trivy is a really easy to install tool that can be run on the command line and can be easily integrated in all the CI/CD pipelines. So for container security 101, really learn Linux security basics. Then load images from trusted registries only. So restrict to only loading from specific registries is always a good idea. So lots of companies also only run their own private registries and even build their own base images and just load all the images from their private registry. Then always scan images for vulnerabilities, automate that in your CI/CD pipeline. say no to root. Also run with an additional command line parameter for Docker in that case to prevent privilege escalation. And do not hardcode secrets into your container image. Always mount these secrets as recommended by Docker. Then always limit your resources to not exhaust your host resources. And also use Linux security modules like AppArmor or SE Linux. So if you have made your security precautions on container security level, then we just move on to the Kubernetes part. When moving to Kubernetes, if you already are a bit familiar with Kubernetes, then you probably will know already that Kubernetes can be a really complex beast. So that's why I always recommend not running your Kubernetes cluster on your own. Use a managed one that is provided by big cloud providers like Google Cloud, Microsoft Azure, or Amazon AWS. So if you use that managed one, then you don't have to care that much about the operational security part of Kubernetes. So you still have to deal with the Kubernetes development security part, like you see on the top of that picture here. So you have to be aware that putting your containers, your applications as part of pods on the Kubernetes cluster should be also secure. So what does that mean to you as a developer actually? So you have to take care about things like role-based access control, putting resource limits on your pods, maybe using constructs, what is called pod security context, pod security policies, or open policy agent. So what are these constructs? The first, resource limits, we have already mentioned that on the container security level. So this is the same approach based on containers. So always restrict the CPU usage and also memory usage. And the next thing is Kubernetes already provides mechanisms to also restrict running with root privileges, to also restrict privilege escalation, to restrict writing on the root file system, and also fine-tune the capabilities. So in that case here, as you see, we drop all the capabilities, so we don't need any special capabilities in that case. So the bad thing about container security context is that you have to specify this security context for each and every pod deployment YAML you want to deploy to your Kubernetes cluster. So it's very easy for developers to forget to put in the security context to each and every deployment YAML. So that's why there's another concept called a pod security policy, which is still in beta. So here the idea is not to put it in every pod deployment YAML, but just to install that pod security policy central on the complete cluster, so that it can be used for all the pods. So the bit more complicated thing in that case is that it's a bit more effort to configure pod security policies, as you also will have to use the role-based access control mechanism. So that's why here is the basics of the role-based access control of Kubernetes. On the right-hand side, you always have a subject, which can be a user or a group. So basically, all developers, administrators are users and can also be part of groups. A service account is always bound to some Kubernetes resource, like for example a pod. So these subjects are now bound to roles or cluster roles by using role bindings. And a role or a cluster role then again points to a target resource or target resources. So basically a resource is anything that can run on a Kubernetes cluster. It can be a pod, it can be a service, and also a pod security policy. But this is a typical configuration used for pod security policies. You have a subject, in that case a service account, that you have to specify as part of the deployment YAML in your pod. That subject then points via role binding to a role, and that role then points to your target resource, which in that case is a pod security policy. And in that way you bind your pod to use that specific pod security policy and restrict it from running as root and all that stuff. Another approach to restrict your pods from doing bad things maybe is the open policy agent. Together with a Kubernetes gatekeeper, this agent takes care of restricting behaviors on your Kubernetes cluster. So it installs an admission controller on your Kubernetes cluster, and now if your developer tries to deploy a pod that contradicts some rules that are defined by the open policy agent, then the deployment is denied by the admission control. So you can really fine-tune here all the rules that are enforced for all the pods running on your Kubernetes cluster. So for Kubernetes Security 101, just follow the container security basics as I've shown, learn some Linux basics. Then always use a managed Kubernetes cluster. It's really hard to run your own Kubernetes cluster, especially if you want to be up to date with your Kubernetes cluster, avoiding all that vulnerabilities happening there from time to time. Then also enable audit logs so that you know what your developers, what your administrators are doing on that Kubernetes cluster, or even be aware of some attacker doing bad things on your cluster. Always enforce authentication on Kubernetes. You can also use mechanisms like OAuth OpenID Connect for authentication there, and enable role-based access control. So it's a bad idea for giving all developers cluster-wide admin access to your Kubernetes cluster. Then use pod security policies or the open policy agent with the gatekeeper to restrict behaviors on Kubernetes. And if you're using Helm, then it's a good time to upgrade to Helm version 3. So Helm version 2 had some component called Tiller, and Tiller basically also played root inside your Kubernetes cluster. So version 3 removed Tiller, so it's a good thing as well to upgrade to the latest version. And one really important point is always monitor your Kubernetes cluster. So if an attacker managed to access your cluster and put Bitcoin miner inside your Kubernetes cluster, at least you recognize that with monitoring it. The last part would be about Kubernetes secrets in Kubernetes. So secrets are spread everywhere inside your world. So it's spread into your applications, in properties, it's spread into your Git repositories in clear text. It's spread what is called Kubernetes secrets that are stored in the etcd database. The bad thing here is that all Kubernetes secrets are stored by default only as base64 encoded values, so not encrypted. So it's a good idea to always combine Kubernetes with what is called a key management system, which is luckily also provided by the big cloud providers. So you can easily connect Kubernetes with a key management system that handles all the encryption and decryption stuff. And as well, it's a good idea to also combine that KMS systems with your Git repositories to avoid storing your secrets in clear text. So always encrypt secret data at rest and in transit. So be aware that in etcd Kubernetes secrets are only base64 encoded by default. Always also restrict interactions with the secrets API using role-based access control. And then also mount secrets into your pod instead of using environment mapping to do that. So environment mapping always has the risk of leaking into logs, for example. That brings us to the final summary of the talk. So Kubernetes is a really complex thing, so always check alternatives. So really check if you really need Kubernetes. So if you only have a simple application, then maybe a better approach would be just to put it into a virtual machine on Amazon AWS, for example. Or check other alternatives like HashiCorp Nomad. That is also much more easier to administer than Kubernetes. Also follow Application Security 101. Make sure that your application is secure, preventing SQL injection, cross-site scripting, all the bad things happening that are stated on the OWASP top 10 list. Then also follow Container and Kubernetes Security 101, as I have described in the last 30 minutes. So ensure your secrets are encrypted in Kubernetes. That's also very important. And also never store secrets in source control, like your Git or Subversion control. And then the last point, check out the demos that are available in the GitHub repository. You find practical demos for all parts that I have described as part of the slides. Unfortunately, only in theory, so the practical part can be found in the GitHub repository. So I invite you all to just check them out, try out, and see how that behaves in practical. So that was all what I had to tell as part of my talk for today. So I'm happy to answer your questions, and thank you very much.